Okay. Number 17, I told my students to omit this problem. There's not a problem on the test that really reflects what's on here, but it is a good challenge if you want to challenge yourself to do this problem, but I'm not going to work it since it's not really related to our tests. Okay, so number 18, find the following distances. All right, so when you're finding a distance on a straight number line, it really just comes down to subtraction. So for AP, A is at 20, or sorry, A is at negative 20, and P is at 23. Okay? I'm going to subtract those two values, negative 20 minus 23. Now, I did it in this order on purpose to show you that sometimes when you subtract these numbers, you'll get a negative number. But this is a length, a distance. In geometry, lengths and distances are positive. This is a length of positive 43, not negative 43. So whatever answer you get, you take the absolute value of to make it positive. Okay? If I did it the other direction, 23 minus negative 20, I would get the same answer. Okay? It's just negative versus positive, and we want the positive answer. All right, for KD, so D is at negative 13, K is at 10. That gives us negative 23. We want the absolute value, we want the positive, so our length is positive 23. For the last one, from I to D, so D is at negative 13, I is at 4. That gives us negative 17. Make it positive. ID has a length of 17. All right, let's take a look at number 19. Okay, get a different color here. Find the following distances. So this line is broken up into a couple of different segments, and it gives us the length for different pieces. So for J to L, it gives us that length is 6. From J to K, it gives us that length is 15. From J to N, that length is 25. And from L to P, that length is 22. Okay, okay. So I don't even look at these. I first try to go in and find as many little segments as I can, and then I look at which pieces they're trying to find. So let's start with, I immediately see that I can get LK by taking JK and subtracting JL. Since we know this is 15 and that's 6, I can use that to get LK. So that would be 9. Okay, so what should I fill? I'll fill this in with orange. So L to K is 9. Okay, another one I see, I could get the whole length of the segment J to P, okay, by adding this 6 here to this 22. If I add J to L and then L to P, that makes the full segment. So 22 plus 6 gives me that J to P is 28, which is also just happens to be one of the things that they're looking for. Okay. Now, why is this useful? Why did I want to do this? Because if we know that the full length from here all the way to here is 28, I can subtract 25 to get NP. So 28 minus 25 gives me that NP has a length of 3. That's also one of the things that they're looking for. Okay. All right. At this point, I don't see an easy way to get Km, so I'm going to skip that. And then I don't quite see an easy way to get Mn. So if we look at what they want here, the nice thing is that they want K to N, not necessarily the little pieces in between them. So let's see if there's a good way to get K to N. All right, well, I know that from J to N is 25, and then I also know that from J to K is 15. So I can subtract 25 minus 15 to give me that K to N would have to be 10. And now I've found all my pieces. All right, number 20. Circle the following pictures which B is the midpoint for. Okay, so really this is just about being able to read a diagram and understand what midpoint is. Okay, for this one, I know that it looks like B is close to the middle here, but in geometry, we only consider something to be true if it is proven to be true, or if we know and we can provide evidence that it's true. Just saying, oh, it looks like it's in the middle, that's an assumption. That's not something that we know. So that's why I don't know for sure that B is the midpoint here. It could be a little bit to the left or a little bit to the right. And since there's nothing indicating that these are congruent, I can't say that that's the midpoint. On the other hand, here, this picture is telling me that the length of AB is 5 and the length of BC is 5. If I know that this side is congruent to that side, then I know that B is right in the middle between A and C. Same thing for this picture. Now I know that this is a very poorly drawn picture. B does not look like it's anywhere near the middle. But what these symbols are telling us is that no matter what this picture looks like, in real life, this segment AB is congruent to that segment BC. It's why we have these symbols. Not everyone can draw perfectly, so even if you can't draw the picture perfectly, we can show the symbols to say, hey, in real life though, these are congruent and B is the midpoint. Okay, in this next picture, we don't know what these lengths are. We know that the length of AB is X and BC is X, but we don't know what it is specifically. But we do know that whatever this length is, it's the same for AB as it is for BC, which means that B is the midpoint. Okay, this last one. Now I know that in this picture, it's telling us that AB is equal to BC, and that's true. Those congruent symbols mean that AB equals BC. However, because these points are not collinear, if we draw segment AC, it's up there. B isn't even a point on the line or segment AC. If B is not even on AC, it can't be the midpoint. So that one's a no. All right, last problem. Okay, it tells us E is the midpoint of DF. So here's DF, E is the midpoint, which means this half will be congruent to that half. Notice, it doesn't say that E is the midpoint of HG. So we don't know that it's in the middle of this line here. We only know that it's in the middle of this line. Okay, it tells us FE has a length of 5. So if FE has a length of 5, that means DE is also going to have a length of 5. and D to F would be 5 plus 5, which is 10. Okay. Then it tells us that H to G has a length of 8, and HE has a length of 5. And it wants to know what EG is. So we just subtract. 8 minus 5 gives us 3. So that means EG should have a length of 3. All right, that's our review. Good luck on your test tomorrow. I wish you well.